Hello everyone, welcome back to DevOps Master. I hope everyone doing well. This is the part 2 of our ultimate DevSecOps GitLab CICD pipeline. If you didn't watch part 1, please go and watch. In part 1, we have shown that how to clone one repository from GitHub to local and how to run application in local, creating virtual environment for our application, and also how to Dockerize your application for better availability and from line 0 from point 0 we have shown that how to dockerize your application, what is docker and everything. So if you didn't watch part 1, please go and watch. And also we have created docker image, docker container to run our application, and in this part, in part 2, we are going to deploy our Kubernetes cluster on EC2 instance, and also we are going to deploy SonarQube, and also we are going to deploy our web application on Kubernetes using Helm-Chart. So please, once again, if you didn't watch the part 1, please go and watch. You will get more clear idea about our project. So without wasting time, let's get started. Okay, before doing hands-on, let me clear you that what is the need of Kubernetes when we successfully deployed our application on Docker and it's running successfully. Okay, let's assume that you have deployed your application on internet using Docker, and at a certain point traffic to your web application is increased and the load is not handled by your server. Because of that, your Docker container is not running. What happens? Your clients are facing issues related to accessing your web application. So to overcome this issue, Kubernetes comes into picture. What Kubernetes does, because of its auto scaling, auto healing and collaboration and load balancing, this is the best container orchestration tool for your application. How? Let me explain you clearly. Kubernetes having a master and node like architecture. In that, what happens means we will having one control plane. Using one master control plane, we will be like controlling the deployment of application in the form of pods. Pods are smallest part of your Kubernetes cluster. Like inside pod, you will be deploying your containers. So indirectly we are controlling the containers in the form of pods. Okay, so this is the Kubernetes, and how it is different from containers, Docker containers. Like let me explain you. It's scalable. Like Kubernetes automatically scale up and down based on the demand, ensuring that resources are being used efficient and application performs well under the varying loads. And second one is portability. Kubernetes supports wide range of environments like on-premises, hybrid and public clouds, providing flexibility and ease of migration. And third point is high availability. With features like load balancing and self-healing, Kubernetes ensures that applications are highly available. If containers fails, it tries to recreate it or like replace with other containers so that downtime is less. So see, these are some features of Kubernetes which makes different from the containers like Docker containers. So basically it is an orchestration of Docker containers. It will create containers and destroy containers on the based on the load and the demand. So let's do hands-on. Okay, before deploying cluster, let me show you how actually Kubernetes cluster is architecture look like. Cluster architecture. Let's go to images. Scroll down. Okay, next. Not getting exact cluster. Okay, let's see this. So let me zoom it. So this is the actual Kubernetes cluster, guys. Assume as these are two servers and two EC2 instances. One is master node and another one is worker node. Master node is also known as control plane and worker node is also known as data plane. In control plane, we will be having these components like etcd, cloud controller manager and API server, scheduler, Kubernetes controller manager. Okay, let me explain you. etcd is like it is a database in which storage system in which whole like information related to our core control plane, how many pods are there, how many running and how many are scheduled and what are the issues, everything is stored in etcd. Okay, this is the actually storage block. Next one is Qube controller. Qube controller, also known as controller manager. It take case about everything is happening in a cluster. If something is need to create, and if something have to instructed like to etcd to store information, or scheduler is like which schedules pods on our nodes, like on worker nodes, scheduling the pods containers. This is the work of scheduler. API server is like communication between master node and worker node. It like if you come to worker node, on worker node we will be having kubelet and also container runtime and kube proxy. What happens means kubelet is an agent of API server which speaks with API server related to how many pods are running, how many need to destroy, and what is the load, everything. And come to container runtime. Container runtime using we are going to like create containers, run containers using container runtime. This is the overview of Kubernetes cluster. And Qube proxy. Qube proxy is like medium between end users and our cluster. End users are going to access our applications using Qube proxy. Okay, this is the overall architecture of Kubernetes cluster. Once I can tell you, this is the etcd storage block of Kubernetes cluster, which stores information related to our cluster. And also scheduler will schedule the like pods, like choosing suitable nodes for our pods. This is the work of scheduler. Qube controller is like controls our cluster, assigning tasks like things. And API server is like communication medium between our master node and worker node. Kubelet is a agent of our API server, master node. And Qube proxy is medium between end user and our Kubernetes cluster application access. Container runtime, which actually runs containers on our nodes. So this is overall architecture. Let's do hands-on now. So this is my master node. If you watched a previous video, you know that we have created master node on which we have deployed our application using container, Docker container. So we need to create more 2 instances like this for as a worker nodes. This one will be our master node. Okay, let's launch 2 more instances similar to this. Click on actions. In that if you go to image and templates, here you will find launch more like this. Click on launch more like this and scroll down. I need 2 instances similar to this, not 12, 2. Scroll down. If you scroll up, here you will find we need to select key pair. Already created new pair. If you didn't, click on create new pair. And VPC same. Okay, I am selecting instance type is T2 micro, and also security group same, and storage is 28 GB up to 30 GB. It is free. Instances 2, launch instance, done. If I go to instances, here we will find that 2 more instances are being created. It's on pending, status is pending. Let's change names of these instances. I will be naming it as a node 1 and 2. This one is node 1 and another one is node 2. Okay, done. Okay, successfully running. Okay, let's do connect to our local using SSH. Copy this URL, come here and move to new tab, CD downloads. In downloads, my SSH key is present. Okay, sorry. And next one, same. We have to connect our node 2 also. Come to our instance block and move on to instances. Here we need to select node 2 and click on connect and copy same URL, same process as we have done for node 1. So okay, let's name as node 2 and this one is node 1, and this one is master node. Rename as master. Sorry guys, master. Shall we change the color? Okay, change the color. This one is red. Okay, yellow. This is master, node 1, node 2. Done. Okay, now we have to run some commands to deploy our Kubernetes cluster. For that, just go to my LinkedIn. I will provide link in description. So just go to LinkedIn. In LinkedIn, move on to post. If you go to post, written one has not blog on installation Kubernetes cluster. Okay, scroll down. Here you can find. This is the guide to outline the steps needed to step a Kubernetes cluster using Qube ADM. Okay, prerequisites are Ubuntu OS, sudo privileges, internet access, T2 medium instance, type or higher, both master and node. We need to run these commands on both master and also on worker nodes. Okay, let's copy this command and come here on master. Okay, it's taking little bit time, why I don't know. Let's copy here and here too, and come to taking some time. Let's run this. Done. So with this, we have done this one, like running commands on both master and worker node. It's done successfully. Next, move on to master node. We need to run these commands on master node only. Initialize the master node. Okay. Let's copy these commands. Come to master and paste here. We need to run this command. Here you can see Qube ADM token create -" print join command. When we run this command on master will provide us one like token. So after copying that token, we need to run that our worker nodes, and also we need to open 6443 port in our inbound. Okay, done. Now we have to run this command. We got our token. We need to copy this token. Okay, for before that we need to open 6443 port. Why we need to expose 6443 port? Why? Because if you come here and scroll up, here you can find that Qube ADM join IP, this master node IP like exposed to 633 port. Okay, that's why we need to expose our 6443 port. Go to security. Here click on security group and edit inbound rule. Here we need to allow port 6443 from everywhere. Save rules. Done. Okay, done. We edited inbound rule. We exposed 633 port. Next, this one is done. On worker node, run the following command on worker node. Okay, sudo kubeadm reset pre-flight checks. Copy this, come here and paste. Yes, so it's preparing our worker nodes for joining our master node. Done. What is the next command? Here paste the joining command. Okay, token which is we have generated, you got from the master node, and append --" v is equal to 5 at the end. Make sure either you are working as a sudo user or use sudo before the command. Okay, let's do that. Let's come to master node, and here we need to copy this. Come to node 1, we need sudo privileges, paste here, and --" v is equal to 5. Done. Okay, done. Same on node 2 also. Sudo paste --" v is equal to 5. Done. If we do here kubectl get nodes, here we can find 2 nodes. Okay, successfully we have deployed Kubernetes cluster, and now we can run our application on this cluster. These are 2 nodes. Okay, this one IP 172, here you come. Okay, 172.31.636. okay, 172.31.636, and this one is 1146. Here you can see 1146. So these are the our nodes, and this one is master node. From here we can deploy our application. So I am going to deploy my application using Helm-Charts. For that we need to install Helm. Okay, we have deployed our Kubernetes cluster on AWS using EC2 instances. Now we need to deploy our application on that cluster using Helm-Charts. Usually we use manifest files, Kubernetes manifest files, for our web application deployment, like defining and configuring application using manifest files. But I am going to use Helm-Charts. Why? Because first of all, what is Helm-Chart? Helm packages application as charts. Charts are set of files that describes the related resources of a Kubernetes files. Okay, it consists of different files like values.yaml, chart.yaml, and inside templates we will be having some manifest templates for deployment, like deployment.yaml. If we see the chart.yaml, it consists metadata related to charts like API version, name, description, and type. If we see the values.yaml consists default configuration values like replica count, image, which image we are going to use, and tag, and service and port. So these are the information will be present in values.yaml. So these data will be accessed by deployment.yaml for the actual deployment of our application. Okay, using Helm charts we can like configure complex Kubernetes applications also. Two major differences are there: manual manifest files and Helm charts. By using Helm charts we can get versioning and also template. Templates are like if you use manual manifest files, they don't have inbuilt versioning, so we can't roll back to our previous version if something happens. And next one is templating. Like if we use manually created YAML files, they can't support multiple environments, but by using Helm charts we can use them in multiple environments. So these are the two major differences between these two set of configuration files, we can say manifest files. So that is, let's do hands-on. Okay, let's install Helm. Just come to Google and search Helm, install, click on first link. If you scroll down you will get that. Okay, let's copy the first command, Control C, come to our master node and paste here. What this will do, it will download that get -helm -3. It's like it will download the Helm sh file. If you do ls, here you can find get underscore helm.sh file. Now next we need to make this file executable. If you do ls -la, here you can see the permissions of that file. Where it is here, you can see this one is like D means it's directory, dash means it's a file, text file or any shell script file, anything like that. And next one is like permissions. First one is like permissions for user, and next one user groups, and last one is like others, other than users and user groups. So these are the permissions. Like user have read and write permission, and groups have read and write permission, and others have just read permission. So we need to change the permissions of that file, we need to make it executable. Okay, so we need to change the mode, chmod. Copy that link and paste here. If I do ls -la, here you can find it turned to green color, means this file is executable now. Now 700 means 707 means read, write, execute permissions. 0 means nothing, only user have read, write, execute permission, and others don't have any permission. Okay, so now we need to execute this file using, I think everyone knows this is the basic thing. Done, let's clear. Okay, let's create Helm chart. Helm, create Helm-chart. It will create Helm chart. If I do ls, here you can find Helm chart directory. Okay, let's go inside Helm chart. If I do ls, here you can find chart.yaml, charts, templates, values.yaml. If you do cat, if you see charts, not chart, here you can find API version, name, description, like that. If I do cat values.yaml, in this we will find that here we will find number of replicas, how many parts we want, and like image, which image we are going to use. Next one, like which port, on which port or your application is going to run. Like we need to mention everything here. So let's do that. Let's clear. What we need to change. Okay, first of all, let's change values, vim values.yaml -i. Okay, next image, we are going to use my image. You know that answer shake 965 slash we named our image as college underscore app. Okay, this is our policy, full policy. If not present, full policy is like if image is locally not present, it will pull from registry, any registry which you have mentioned. Next, scroll down, service, which service you want to, we need to make it our application accessible from outside of cluster. Okay, through internet. So to that we need to use node port. Cluster IP will expose our application inside the cluster on node only. To make it accessible from outside of cluster, we need to use node port. On which port our application is running, I think 8000. Okay, ingress is false. Scroll down, and here scroll down, and that's it. Escape, save it, escape : wq, write and quit. Okay. Next one is, do we need to change anything in charts? No need. Let's move on to templates. Let's here we need to change deployment. Vim deployment.yaml apps version 1 kind deployment. Okay, done everything. Here you can see metadata name. It will take as a Helm-Chart, labels, specifications, selector, templates. Okay, specification you can see values.image pool. It will take image from values.yaml. Okay, ports, it will take that too from values.yaml. We scroll down, protocol, ports, values.yaml. Okay, done. Escape wq, and again what is service.yaml. Let's try to change service.yaml also. Escape vim service.yaml. Sorry, let's change here to target port is 8000. Target port must be let's say 7000. Protocol TCP, it will take from there. Type also it will take from there. Okay, done. Save. Now we need to go back to our repository. Done. ls. Okay, we have done modifications for our application deployment. It will pull image from our Docker hub, and on 8000 port it will deploy our application. Okay, we use service as node port for when application is deployed, we need to accessible, it can be accessible. Okay, for that we use node port. If you want to make it accessible to everyone, we need to use external load balancer. Okay, load balancer service or ingress service for that. But now we are using for video, we don't need load balancer. With node port also our work will be done. Okay, we need to apply changes now using helm install. Okay, hyphen name, we need to provide name for our application. I will be naming it as college app. Oh, sorry, college app. Now helm charts. Okay, done. Enter unknown flag name. Okay, let's remove that. Now let's try this. Done. Deployment is created. Sorry, kubectl get pods. Image pull back off. Why? It's saying that image pull back off. Okay, error in image pull. Let's check our image is correct or not. Vim values. Let's check. Answer shake 965 college. Correct only. Let's check once again. Docker hub. We need to log in. It's correct only. We can use this to also describe pod. Okay, what happening? Pulling image. Okay, why it is taking default value 1.160? Okay, we need to, here you can see it's pulling college app colon 1.16.0. so this will be wrong, that's why it's getting error and pod is not running. So we need to make sure that it can't take that value. Okay, cd Helm-Chart. Okay, values.yaml, vim values.yaml. Done guys, it's running successfully. I will explain you what happens. Here you can see first we have pull policy, means tag is after pull policy, it will execute command in sequence. So that's why what happens, because of tag is not accessible to the image, it's taking the default app version as a tag. So because of that Helm-Chart is Kubernetes is not able to access our image, Docker image. What I have done, I have made tag before pull policy. So that's why Kubernetes is able to access our Docker image. So that is the problem. That's it. If you see now, if you go back and see, our application is our pod is running successfully. Okay. If I do kubectl get svc, okay, here you can find on node port. Actually, our application is running on 8000 inside the cluster. We exposed our application to node port using service node port. So node port will have some range of ports on which application can be exposed. So because we use node port, our application is exports to this port 32658. So if I copy, okay, if I go back, if I copy IP address of my node, and it's working, guys. If I do admin, you can go to admin page also. Let's go here and search for what is the username. Try Elias. Copy this one. Project 123 is the, and project 123. Successfully running. Application is successfully running, guys. In part 2, our 2 tasks are completed. We have deployed Kubernetes cluster, and also we have deployed our application on Kubernetes cluster. Next, now we need to deploy SonarQube. Let's do that. Okay, let me clear this. We need to, like, using Docker, we are going to deploy SonarQube for our application code analysis. If you see this code here, this code is there now. This code will be analyzed by SonarQube for any vulnerabilities or any bugs. If there anything, it will analyze that and send notification to us. So because of that, we are using SonarQube. Using Docker, I am going to deploy SonarQube. You can directly install in your operating system, but I am using Docker file for SonarQube deployment. So how? See, Docker run --name sonar -d -p. SonarQube will run on default port 9000. Okay, 9000 SonarQube LTS latest -community. Okay, done. It's pulling the image and it will start running container, SonarQube container. So for that, we need to enable 9000 port 9000 on our security group. Go to security and edit, sorry, inbound rule. We have to edit inbound rule. Okay, come here, edit, add 9000. Okay, so if we come, if I do docker ps, our here you can see SonarQube container is successfully running. So I need to go here and select EC2 instance, master, copy the IP, public IP address, details, copy public IP and paste here 9000. Loading. SonarQube is also, here you can see SonarQube also running because it will take some time. Yeah, default login is, username is admin and password also admin. While logging, it will ask for us to change our password. Here you can keep stronger password, admin 123, admin 123. Done. No thanks. So this is the overview of SonarQube, guys. Done. SonarQube deployment also done. So that is it, guys. Part 2 also completed. Next, in part 3, we will be creating GitLab CICD pipeline from scratch, from line 0. I will be explaining you how to create one GitLab pipeline, CICD pipeline, and how to write GitLab CI YAML file for deployment from line 0. I will be explaining what are variables, how to install runners on GitLab, and how to use shared runners and what are shared runners, and how to enable monitoring using Grafana and Prometheus, and how to deploy Grafana and Prometheus, everything. So please, if you like this content, please don't forget to subscribe and click on the bell icon for the notification whenever I post the video. We will meet in next part. Take care.